In this fast video or short video, we are going to look at what it means to have parallel or perpendicular vectors. So first, perpendicular vectors are called orthogonal. Vectors are perpendicular when the following happens. If you take u dot v, that's going to give you 0 as a result. That means that they are perpendicular, or defined as being at right angles. Vectors are parallel when you can multiply one vector by a scalar and you get the other. Okay? So, the first example here we're going to look at is the fact that you were asked to find two vectors that are orthogonal to the given vector. Essentially meaning that when you take the dot product, you get 0. Okay? So, for example, we have 2 and negative 6. So one possible vector for v would be the idea of 6 and 2. Because when you take the dot product, remember the dot product is u dot v is going to be u1 v1 plus u2 v2. So if you look at this, if we use 6, 2, then take a look at it. I would have 2 times 6, which is 12. And I'm going to add that to negative 6 times 2, which is negative 12. When I add them together, I get 0, thus orthogonal. Okay? Another possible example would be things like the vector 3 and 1. Or you could use something like 12 and 4. You could also use negative 6, negative 2, and so on and so forth. There are so many different ways that you could find some orthogonal vectors. You just have to get in the habit of being very comfortable with looking at the idea that your dot product has to be 0. Okay? Now, in the second and final example, you need to determine whether u and v are orthogonal, parallel, or neither. Meaning, are they perpendicular, parallel, or neither? So you have to apply the two rules that we have by looking at the vectors. So if we look at this, I have vector u, which is 12 and 30, and I have vector v, which is 1/2 and negative 5/4. Initially, when we look at these, the instinct would say, oh, that's got to be neither because of the fraction. However, if we compute negative 24v, can we get u out of that? So negative 24v is going to be negative 24 times my components 1/2, negative 5/4. And what I'm hoping is that I get negative 12 and 30. So if I look at that, or remember, the math says that this would be negative 24 times 1/2 and negative 24 times negative 5/4. So let's take a look. Negative 24 over 2 is going to leave me with negative 12. Negative 24 over 4 is going to leave me with negative 6. Negative negative is positive. 6 times 5 is 30. Now I know I did that kind of quickly, but that's the idea behind what it is you have to do. Because we were able to find a scalar that we could multiply this by to get our others, these ones are considered parallel. Now with my others, notice I'm given the linear forms. Okay? So here I have my u is going to be the component 2, negative 2. And I have my v, which is going to be the component negative 1, negative 1. So first and foremost, there is nothing that I can multiply either of these by that's going to give me the other. And the reason for that is because both of these are negative, and on the other, only one of them is. And so there's no way that we can do anything that's going to make them equal. So they're not parallel. But we have to check, are they perpendicular? So we need to look at u dot v, and we have to find out, does it equal 0? So here, this is going to be 2 times negative 1 plus negative 2 times negative 1. 2 times negative 1 gives you negative 2 plus 2, which equals 0. This is what we're checking. And in this case, 0 equals 0. Therefore, this would be called orthogonal. But the other way that you could label it would be perpendicular. So essentially with these, it's just a matter of applying the definition that you have and seeing if it works. Now obviously, if neither of the definitions worked in these cases, then it would be neither. So that's everything you need to know about parallel and perpendicular vectors. If you just simply remember, perpendicular means that the dot product equals 0, and parallel means that you can find a scalar that makes it the same. So I hope you enjoyed this very short mini lesson on parallel and perpendicular vectors. If you have any questions, let me know. Otherwise, have a great afternoon or morning or evening, and I will see you next time.